Alright, honors, you guys need to know KSP. So, in terms of solubility, you're going to need to know that for equilibrium. Remember, you're going to write out your expression. So KSP always equals just the ions. So I could give you calcium hydroxide. That's all I have to give you to ask you what is the KSP expression. Because for KSP, it's always going to dissociate into its ions. So it would be Ca2 plus OH minus. Maybe like that. Alright, so that's what you would write. When you do that, in the case of this, to do the KSP expression, it's just going to be zinc, and it has no coefficient, so it's not going to be raised to any power. OH is going to be raised to the second power. Now when we plug in numbers, in this case they told them that the KSP is 7.7 times 10 to the negative 17. So we're looking actually for the concentration of what dissociated. So when we do this, we have to plug in the coefficients again. And if you look at the ICE tables when we just do K, it's actually built into that. That's why we didn't do it for just the regular K expressions. This is actually built into the ICE table. So in this case, zinc doesn't have any coefficients, so we're just putting X in there. There's 2 of these, so it's 2x, and we already know it's squared. So when we do that, that's 4x cubed, and then you just do the math. When you get X, X is going to be how much of the zinc hydroxide dissociated. So if it just asks for how much dissociated or the concentration that dissolved or was soluble, you don't have to do anything else after you get X. If it asks for the concentration of the OH ions, then you would take this and multiply it by 2. Because every time when it's dissociated, you made twice as many hydroxide. Does that make sense? Okay. Questions? Alright. I don't necessarily care as much that this says precipitation reaction. What I want you to see is the net ionic equation. So if I give you a reaction, either written out in words or given to you like this, I said find the net reaction, net ionic reaction, you're going to look for only the things that form that solid. So if I look at this, this is my solid. So the net ionic equations are only the things that are relevant to making that solid. So what things do I use to make that solid? What's in?
PV.
PV. Alright, PV and I. So that's where I get them from. So first thing I'm going to do is I'm going to separate everything into its ions except the solid. Everything else gets separated. So charges, we balance it, whole 9 yards. So that's our ionic equation. We've broken it up into its ions. The next thing we do is cross out everything not involved in making that solid. So sodium, nitrate, none of those were involved in making it. We cross them out. So we're left with lead 2 plus, 2I minus, and that gives us PbI2 solid. So that is the net ionic equation. And the spectator ions are the ones you crossed out that weren't involved in making the solid. Any questions? heat of the reaction. So we covered this already. It's just the bonds broken minus bonds formed. Same thing. All right, ice tables. Regular chem, you might want to pay attention just in case this shows up. So it says for the reaction, it gives you a reaction. K equals 0.044. Complete the ice table for the initial conditions, and this, if it didn't say ice table, initial conditions should have given it away, where CH4 equals H2S, and both of those equal 0.33. And CS2 is the same concentration as H2, and they're both 0.44. So in this case, we actually have some product and some reactant. So we do our minus x minus 2x plus x plus 4x. And then we add it down. 0.33 minus x, 0.33 minus 2x, 0.44 plus x, 0.44 plus 4x. And then we would write our our K expression. So in this case, what's it going to be? Yep, products over reactants. So we have concentration of CS2, it has no coefficients, over the concentration of H2 to the fourth, so it has 4 there, divided by concentration of our CH4 times our H2S to the second. And then we plug in these terms, okay? So those would go in here, those would go in here, and you would solve. Questions? This should be pretty fresh in your mind, things. Let me just finish this. All right, Le Chatelier's principle. Remember that this is going to shift the direction that will even the teeter-totter back out. And yep, when you're taking your final, I expect to see people out there going. I expect it. I know it's going to happen.
I know.
All right. So if I add H2, I now made this side of the teeter-totter heavier, right? So it's going to go down. Well, which way do I need to add something to make it even back out?
Right.
So I need to go to the right and make more. Same with the N2. If I add more of that, it's going to go this way. Now if I add to this way and make this side heavier, which way does it have to go to balance back out?
That side.
It has to go that way. Now this is an exothermic process. It's hard to see, but if I add heat to this side, so it's already exothermic. I'm telling you, this is part of the equation. If I add more heat to this, which way is it going to shift?
You add heat, right? So it's going to go that way.
It's going to go that way, because essentially I just added product. I made this side heavier, you can think of it, by adding more heat. So it's going to go that way.
It's on the right.
Yes.
You said it's exothermic?
Yeah.
So wouldn't that mean that there's less energy for the products?
No, it's giving off heat.
So,
So it made
more
this
heat.
and gave off heat.
Okay.
So if I add more heat, I'm adding to the products.
Right, because you
So it's going to
you
shift that way.
So if
add
you
heat,
decrease the
gave
heat,
off
would go
more
to the right?
If I decrease the heat, if I'm pulling off this heat and cooling it down, then yes, it's going to shift to the right because it's going to fill that void. Now if I make the container larger, which way is it going to shift?
So if you made the container larger, the volume would increase, therefore the pressure would decrease.
So which way is it going to shift? So it's gonna shift to the side with more moles. Because it has more volume it needs to fill with collisions. So if you decrease the pressure, it's gonna shift to the side that has more moles, so they can make more of what can have more collisions. If I increase the pressure, I want less collisions, so I'm gonna shift to the side that has less moles. And we determine that by looking at the coefficients. 4 versus 2.
It will go to the side with less moles. If you decrease the pressure, it will go to the side with less moles.
If you decrease the pressure, it goes to the side with more, because it wants to increase the pressure again.
Yeah, so it decreased the pressure. So you're gonna go back that way?
You decrease the pressure, it wants to raise it again. And to raise it, we need to make more of the side that had more moles.
Yeah.
Alright, questions? Gas laws. These are all over your desk to honor